then I need to send some commands to the device, either to store something. If it is a memory, for example, I want to store something to the memory, or I want to read something from the memory, something like read and write, right? So device has to have some program, okay? That program understand this device, okay? Some kind of gateway. So every device will have some small software, that small program. And this software, basically what it does is it provides this set of interfaces, how to communicate with the device, depending on the nature of the device. Okay, if it is the kind of bi-directional device, means you can send some information to the device, and the device also can send some information, then it's a bi-directional, right? So it will have something like read, write, and so on. Some say some program will be there, some say, and some API, okay, will be provided, okay, for every devices. So those devices are called kernel, okay. So sorry, device driver, okay. For every device, you need to have a device driver, okay. Likewise, what we have, so if you look at the core operating system, Linux operating system, that is nothing but this kernel, okay. So in this kernel, what you are going to have is all those, say, device drivers you are going to have. And again, along with the device driver, you're also going to have some other managerial programs, like say when you have many programs trying to say access some resource, then you need to manage those say programs, right? So you need to manage the say storage, you need to manage the CPU, okay, like say you need to like process management system modules, then memory management modules, and so on. All those managerial say modules, okay, that will those also will be part of the say in the kernel. So kernel basically have is all those very low level modules, okay, to connect to the devices and to manage those devices and so on, okay. So that is the kernel, okay. So basically your operating system is this kernel only, right? So but if you look at kernel, you have only very few limited say functionalities. Then again, this kernel, okay, and the user level program, okay, you also need to have some interface, because kernels are in the very low level. So when I write a very high level program, right, uh, so I need to, I cannot directly access the kernel part. So again, kernel will also provide some set of APIs that will again say same thing. Okay, it's a external higher level program can communicate with the say kernel. Okay, those set of APIs are called system call. Okay, so system calls are again another set of say API to connect between the kernel and the say higher level. Okay, so the moment I have these system calls, maybe that now I can, anybody can communicate with the kernel. Okay, so that is the idea. So again, then we have C programming, and then C compiler, and so on. Then again, if you look at in the Linux, the moment you log in, you have something like terminal where you can submit some commands and so on. So that cell, okay, that is the cell program. So cell terminal. So that cell terminal itself is one another program, high level program, that so this cell will take some input, okay, like in the form of a command. So whatever command you are typing, that is what we're going to see today, will be taken as the input by that program, this cell program, and sent to the kernel through say system calls. Okay, so likewise, then again, if you're using want to write some C program, then C will have some library, or Java program, Java will have some library. So this set of standard library means for some standard say application, generalized application, you need to have some underlying pre-implemented modules, those libraries. So those things will be also residing above the system calls, because your libraries are already in the high level program. Okay, so it's just a module, then it will perform some action to the kernel. So it has to communicate through system calls. Okay. So likewise, some low-level libraries you can have above this. Okay. Then so some low-level utilities like shell programs and so on, you may have above this. Likewise, all the Linux utilities, like say checking the creating directory, uh, checking how many files are there and so on. This says system level utilities are also will be they will be residing above this. Okay. Then again, on top of this, again using the high level program, you can still create another high level libraries and so on as a wrap up that can go on the higher cell and so on. You can go develop another library using the predefined library as a wrap up kind of things. Then you can go above this and so on. So it's a kind of layer by layer system. Okay, but if you say operating system, core operating system is nothing but a kernel, and all other things are kind of APIs providing, APIs provided to communicate between the low level and high level. So this is the kind of overview of Unix system. Okay, but again, Linux and Unix, because Linux is based on the Unix kernels and so on. So Mac, say any Unix variants like Linux, Fedora, Ubuntu, and so on. These are all based on the Unix kernel. So basic commands. Okay, that's why basic commands are there. Are lots of commonality in the basic commands. Okay. So this is the high level, say, overview of the Unix operating system. Then again, if just to again give another more clear picture understanding. So this figure I have collected from the web source. It shows that, okay, in the lowest level you are having the hardwares. Okay, then you have the device driver connecting between them. Then you have say operating system is so Unix operating system. If you see above the hardware, process management, memory management, file system, I/O, etc., and so on. Okay, this is for the all the device drivers and the managerial programs. Okay, then between the library, okay, standard library. Okay, here you can also have cells and so on. So this open, close, these are the kind of say low-level APIs to communicate with the say kernel. Something like I want to write something on in the memory. Okay, so this write is the low-level API. Okay, so when I say something like in the C program, you may have something like a scanf or something, or say you are writing something on the hard disk, right? So that time you or say you are sending something in the say main memory. So for that I have to use this write low level write API provided by the kernels. Okay. So likewise you have the set of system calls at this between this standard library and the kernel. Likewise again between the standard library, say you again have high level utilities library and so on. Okay, this is what the stages. Okay, so that's it. That's it. Okay, that is the just brief say 1 minute explanation of how say operating system or Unix operating system looks like. Okay, so again everything in the Unix is all files. Okay, and these files are stored in a hierarchical manner. I think you are already aware of this, right? You have something called a root directory, and everything is inside this root directory. And inside this root directory, you may have various other subdirectories, okay, depending on the purpose. Okay, so some again, this figure is also taken from web, so you can see depending on the different Linux variant. Okay, these directories might be different. Okay, so if you look at on say Mac, many of them may not be present. Okay, but in Linux, Fedora, and Ubuntu, many of them might be common. Still, there will be some differences. So different variant may have different structure. That is okay, but everything is in the hierarchical tree structure. Okay, so some of the things, some of these directories, standard directories, we know that if say under the root you have something called bin. Okay, maybe I will just show you. If you are already using Linux, then you can also a laptop with you, you can also check. So, so this is inside my root directory. What are the other directories? Okay. So here, if I see, I have bin here. Okay. I have etc. I have home. But what you see here maybe will be different from what you see on your laptop. Okay, because operating system is different. So like you have say sbin, you have temp, you have user usr, you have var, and so on. Okay, and you can also see what is the structure using the command hier higher. Okay, but I cannot run this on Mac, so I cannot show, but I can show you how it is. Okay, so if you type hier this command, you can see what are the structure that you have and what are the corresponding description. Okay, if you see here that root is the root directory of the file system, that is beginning point. Then you have under root you have bin. Under the bin you are storing user level executable commands. Like user level basically means say some of the commands that are developed for say user utilities. Okay, those kind of commands, these are the kind of standard, but it doesn't mean that you cannot put in the other places. Okay, so this is a kind of acceptance. So you have some kind of user say level utilities in the bin, and the device related file in the dev, and all the configuration file in the etc. And the make kernel, this is a different. Okay, in your case you may have something like boot and so on. So sbin is again all the system level utilities we have in the sbin. And when you run some program, some temporary files, many temporary files will be created. Those temporary files will be stored in the temp. And any user level programs, okay, say that may be stored in the user directory. And some other miscellaneous say that programs can be in the var and so on. Okay, likewise everything will be under the tree. Okay, so I will just show you where I am. Okay, so at present, if I say pwd present working directory, this command, you can see that I am inside users. Under the root, I have a directory called users. Under that, I'm having say SRS. Okay, but if you type on your system, Linux system, you will be having something like home. Under that home, you will have your username, something like suppose your name is something like James or something. You will have something like James. Okay, so it says that you are, so your working space, this the home directory. Home directory means, and as you know that in Linux is nothing but multi-users platform where you can many users might be working, right? Earlier, like Windows 95 and so on, they are single users, don't have multiple users. Okay, so Linux, you have, it is a multi-users platform. So for every user you will have one workspace. Okay, so that is called home directory. Okay, home directory is like your home, you can do anything inside that space. Okay, so when you log into your Linux system, you land up at some directory, right? That is the home directory. Okay, so if I am James, then when I after logging in with James user, I will be landing up something like this here. Okay, so James is under home. Okay, home directory, and the home is under root. Okay, inside home I may have multiple users. Suppose if I have James, also another is Ram also, then Ram will also be inside this. I will also have Ram. Okay, something like that. So for every individual users, you're going to have one working space home directory, that all those that will be created under this. And any files, any directory that you are going to create under your home directory will be starting from here. Okay, and everything will be under this say home directory. Okay, so in my system, I am at these users. Under users, I am my username is SRS, so I am having SRS. So if I have multiple users, I will have another under this users directory, I will have another users and so on. Okay, so that is everything is in the tree structure, and all the files are maintained in that. Okay, so these are some of the standard home directories. Okay, but you may find some differences. So this particular branch, what is trying to say is, in this particular figure, I have two users. One is that student, another is the Linux gym or something. Okay, so student is under home, Linux gym is also under home, and inside the student you have just created one directory called dir. Okay, that is inside this. So this dir, the last one, it is one directory that you have created. Okay, it will be, you can see that dir is inside the student. Okay, so everything you create inside will be inside your home directory. Okay, so that will always be kind of you will have the prefix like home slash home slash students and so on. Okay, likewise another is inside the user there are one directory called local, user local. So these are all standard directory, you can easily see. Okay, if you just expand you can see all those things. Okay, okay, so likewise inside the local I have created two directories called bin and the games and so on. Okay, so like everything will be in a tree structure. So this is how every file, every say directory that you create, or say you create in your system, say in your home directory or in the system level, will always be will look like something like this. Okay, and there are many files already in your system. They are already in the this particular tree structure, and I'm sure you might have seen this and you have already experienced this. Okay, since you have used this operating system in the last semester. So what are the things that we are going to learn, okay, in the next few classes? So I'm just going to quickly show some of the utilities. Okay, so you have various forms of utilities in various classes, and and the majority of these utilities are under file processing. Okay, so this, ignore the table numbers. Okay, this because I have taken this figure from another book. Okay, so that this table is the table number 8.1 in that book. Okay, so this the list of commands that I'm showing here. Okay, they are file processing utilities, like how to create file, how to see file, how to process that file, and so on, how to compare to file, how to copy, and so on. So we will not be going through all these utilities, but in the next few classes, okay, we'll try to cover majority of these utilities. Okay, so likewise, so we'll look at few of them today, and I just wanted to show that, okay, already you have so many utilities and you can do many things. Okay, this is file processing utilities, this is also file processing utilities, this is also file processing utilities. So file processing, you have many utilities. Okay, so this is about system status utilities. You want to check, like say you want to say how many processes are there in your program. You want to check who is the current users. You want to check how many users are currently logging to your system, because suppose you have your machine is in a network, then remotely many people can log into your system and work remotely, right? So how many users are looking at, and some process is taking lots of resources, how to kill those resources. Okay, what is the memory size? Okay, and likewise how to set the system. This is the kind of some form of administrative utilities to check the system status. Okay, so we will also look at some of this, and okay, so, and these are not very difficult to, you can also try all these utilities. Okay, then again, network utilities, say to connect to remote, to connect remotely, FTP, you can do file transfer. Okay, you can check the configuration of your network. You can check what is the current network status, routing table for your networks, net stats, and so on. These are again some of the utilities, okay, for managing the network. Okay. Then this is also some utilities for sending email. Suppose you are in the network, suppose because all your computers are in a network, right? So I want to send one message to another, one of your friend in another machine. Okay, I can send some message using talk, then using wall, and I can write something on your their say login home page. Home page means when you log in. Okay, I want to send a message so that when he logs in, he can see the message and so on. Likewise, you can send message from one terminal to another terminal. Okay, these things, some of the communication utilities. Likewise, some security. So this is one. This is something that you are going to use very frequently. Okay. So whenever you create a file, okay, in the Unix system, you have already seen that everything is a files and directory. And why we say that Unix is or Linux is secure, because you set some permission to all these directories and the files. Okay, and only those authorized users having that access permission will be allowed to access. Okay, so how do you do those say permission changing and so on? Okay, so these are some of the commands, say change mode, change owner, change group, and so on. So this will using this set of commands, you can set permission, you can change permission. Suppose I have created a file and I don't want anybody to see, because your computer will be in the network or multiple users will be using your computer. So I just want to limit myself this file to only myself. I don't want to anyone to see it. Okay, then I have to change. I can change the permission. Okay, like with change mode I have to use, and so these are some of the commands. Like again, this is again for the network. IP table is for looking at your routing tables and so on. Okay, and changing the password. And these are some programming utilities. Make, I think we will be looking at make. Others, I think these are programming, so you don't have to do. And another very interesting utilities. Okay, and if you are writing some big program, then I also would suggest that you should probably use some of this. So you may have heard about Git, right? Today, I think Git is the most popular, say, revision control system, or say versioning system. Okay, but Linux itself provides many tools for versioning. Okay, like so C in C out. This is C in C out is again one versioning tool. When you write a program, you can check into the system and create one version. Okay, then you can see out is a check out. You can check out the system, the one that you have so check in, and again modified and so on. So Unix system itself provide many say versioning system. Okay, so like check in, check out, CBS, RCS, RLog, and so on. These are the Linux default system. Okay. But I think now it is say maybe around before 20 years when I was doing say studying that time we had to use all these things, but nowadays no one is, I think, going for this. Maybe GitHub you are using, right? So exactly say in similar to GitHub, operating system also have this say versioning system. Okay, then okay, these are again some other uh, for maintenance system, like say fdix for checking the when if some files are corrupted. You can I also do not know all these utilities, but some of the utilities I have used, like fsck. If your file is corrupted, suppose when if you do not properly say shut down your system, when you boot off, then your file may be corrupted, right? Then you need to say repair your file. Okay, so then fsck is one of the command that you are going to use very commonly. Okay, so many times it happens to my system because I don't have UPS. Suddenly switch off when you have the power cut off, and then when I boot off, many times I had to fix the DIX and so on. FSCK is one command that you can use. Then cron-tef is another interesting tool. Most likely you will be using. This is like, say you have a program and you don't want to run. Say you want to schedule that. Like I want to schedule something like at this particular hour of this particular day of this month and so on. You run this, or say every night at 10 p.m. you run this particular program and so on, or this particular. So likewise, if you want to schedule something, okay, then you are going to use something like cron tab. Okay, so likewise, these are the, I think, other utilities also you try to look at. Okay, but these are the say set of utilities. Okay, so you have many utilities, but some of them we will be covering in this course. Okay. So again, since we have many topics in the course, maybe we are trying to cover these commands with these utilities maybe in next 2 classes or 3 classes. After that, again, we'll be moving to different topic. Okay. So today, what I'm going to cover is are this set of commands. Okay, so let me go one by one. So now I think you already know what is main, right? Main is like manual. You have many commands, and I want some help. I want to know what is this command about. Okay, then I can directly open manual. Okay, man is the manual. You give any command. Okay, any system level command where the manual is already kind of say part of the system. Okay, if I say main ls is one command, so I can see these are the descriptions. Okay, I have the command ls, and there I have many options, say options and so on. This will give me the complete description of this command. Okay, so this is main. So similarly, I think info also you can use. Okay, info also give me the same information. Okay, so what happen is info is also one for some commands added later on. You may have information say in the main, or it may be integrated with info and so on. So it may happen that for some commands you have manual but not info, or say you don't have manual but it is added in the info and so on. Okay, so if you have some but I think most of all these standard commands, okay, they are added in both the cases, so you can use both of things. So if you want any help for any commands, because remembering these commands, okay, if each command will have many options, and maybe hardly 1 or 2 options you are going to use very frequently, and some options will be occasionally used in certain situation. Okay, so it's very difficult to remember, and it is not expected to remember as well, right? So you have to frequently refer to those manual. Okay, so even if I have been using ls for maybe last more than 20 years also, but I do not know all the options that we have in ls. Okay, so only few of them you are going to use. Okay, so you always need to refer to some manual. Okay, so if you want to check some manual, you can use either info or main. Okay, then suppose you want to locate. Okay, before that, I want to check uh, who is the person currently logged in. Okay, so who basically says uh, the list of users who logged into my system. Okay, and who am I? Who am I also gives me who I am. Okay, so you can see who are the person using login, and who is the users. So who is the users? Then you can use who am I and who. Okay, then I want to check, because every command is a program, right, residing somewhere in the operating system, and I want to check where is that program stored. Okay, so because we have many directories, and some command will be stored in one directory, and some command will be stored in another directory, and so on. Then sometimes I need to probably know where in which directory this particular program is stored. Okay, so likewise that I can okay, then for that I can use where is command. So where is ls is the command. Okay, I want to check where it is installed. You can see that it is stored inside bin. Okay, inside the bin directory, this command is stored. You can see my terminal, right? The font size of this terminal seems to be small, but can you still read it?
Yes, sir. Yes.
Okay. So likewise, this where is, you can using where is, I can also I can check out okay, where is the where is this command stored. Okay. Then again, so that is some command. So I haven't explained about what you see here. Okay. So when you log in, then when you open your terminal, okay, when you log in, then you are in the home directory. Okay, so this prompt basically give those information. Okay, it says that the name of my computer is this one, SRS, MacBook, and year and so on. Then who is the user? Okay, this SRS says this is the user. Okay, then where you are, this tilde will say that okay, you are in a home directory. Okay, home directory is often defined by tilde. Okay, this tilde will tell me okay, say I am in a home directory. Okay, so the way this prompt is displayed, okay, it will be different from different operating systems, but you may have different things on your terminal, but ideally these three information will be there: the name of the machine, the username, and where you are. Okay. So if I move to some other directory, just let me try to move to some other directory. So when I move to another directory, okay, so now instead of home directory, it is changed to the directory name. Okay, so this one says this tilde, that this position in on my machine is showing what is the name of the directory where you are. Okay, but in your machine, okay, your prompt might be username is first, after that you have the directory and so on. That may be different. Even the way you want to display, say this, the way you want to display can also be customized. Okay, you can also set your own the way you want. Okay, so that you can also change. Okay, so this is about this display. Okay, so I wanted to explain. Okay. There is a command called tus. I think you might have used say tus command before. Can anyone tell what is the tus?
Sir, it creates a new file.
Yeah. So yes. So when you okay, before going to tus, let me. I'm also sure that you have used cd. Okay. So cd will just change directory. You can go to different directories using cd, right? Then again, cd has. So if I just say cd dot, it says change to present directory. That dot says that present directory. If I say dot dot, it says go to the parent directory. Okay. If I say dot dot, it is moving to parent directory. So now, so if I am pwd, I am inside the test under the SRS directory. Now if I if I just put dot, it is in the present directory, so I don't, nothing is changed. I still in the present directory. If I put dot dot, go to the parent directory. So if you check, this is the parent directory, right? So I am sure. And again, if I want to go to a specific directory from here, say something like talks. Say this is users SRS, because I need to define the entire part, right? Say inside this, and then students and so on. I can go to different directories. Okay, So what I just did is I have given the entire path starting from the root directory, because from root directory to the users, say users and then student and so on. Okay. So if I know the root directory, entire part of the place, the particular directory where you want to change, then I can specify the complete path. Okay. But again, your complete path might be very long, and the one where you want to go is very close by your place. Then instead of typing the complete directory, so I can just type. So this is inside the students. I want to go to inside students. So I can just say student is in the present directory. Okay. And from the present directory, you go to the student. Okay. I can do that. So, or say, if it say it is under the parent directory, you go to the parent and go to this one. Again, if you want to go 2 level higher, parent to parent, grandparent, I can go something like this. So I can go any upper side. So using, let's say, subsequent dots. Okay. So likewise, I can move from different places to different places, either by defining the entire part or by showing the part, something like this. Okay. So this is the change directory. Okay. So now I am sure you have used ls many times. Ls basically tells me the list of directories and files that are present inside a particular directory. So when I say ls only, it is showing the list of files and directories in this manner. Okay. So ls have many options. Okay. So these are the list of options that you can use. Okay. These are the list of options. You have many options to use. Okay. So and only few of them. Okay. We are frequently using. So we remember only those few of them. So ls minus l. So you need to look at and get familiar with those options. But quite often, ls minus l or ls minus al or minus a and so on. Some only few of them you will be using it, uh, frequently using it. So those frequently using options you need to remember. So when I see ls, I only have the names, but I don't have the other meta information of the particular files or say directories. Okay. So if I say ls minus l, it will also give me the other information. Okay. So so if I say ls minus l, it shows something like this. Okay. And if I give something like al, it will also give hidden files as well, because the files with the dots you have here, these are some form of hidden files that basically these are meant for some configuration files that user no need to see. Okay. So if I give a, it will also show me the hidden files. So so if I just give ls minus l. Okay. So then you see that there are many information along with these file names and directory names, right? So the first character, it shows whether it is a directory or is it a file, is it a link, and so on. So if you see here, this one, the first one is starting with D, right? If it is starting with D, it says that this is a directory. And in some cases, you see that you start with this minus symbol, hyphen. Okay, so instead of D, you have hyphen here, this minus symbol. It says if it is hyphen or this minus symbol, it is the file. Okay, and in some cases, you may also have L. Okay, L means you are having a link to some other file or directory. Okay, link is like a shortcut. Okay, you want to put a shortcut to some other files in some other folder. I can create a link also. Link. So links are of soft link and a hard link. Those we'll look at later on. So you can also have something like L. If you have L, then this is the say link to the soft link to some other directory. So that particular file is physically stored in some other directory, but you are linking from here. Okay, so I may also have some link here. Let me just check. Yeah, any link. Unfortunately, I'm not having any link. Okay, let me just. Okay, here also I don't have link. So, but anyway, link, how to create link we'll look at later on. But again, so if you have a L, that basically means this is a link. Okay. Then, so next, then after that, you can see there are 9 characters. W, R, W, X, R, W, X, and so on. Okay, these are basically the permission, okay, to this particular directory or file. Okay, so because of this permission, Linux system become secure, right? So only the users who have this particular permission will be able to perform and the associated say action okay, to say on a particular directory or file. Okay, so you can see that permissions are repetition of R, W, X. The pattern is something like this. So I think you can see the last one. The last one you have R, W, X, R, W, X, R, W, X. Okay, so these are the permissions. So the first 3 characters, okay, define the permission associated with the user. User means the one who logs in. Okay, in this particular session, I am the user. SRS is the user. Okay, so the SRS user can perform say this 3 operation. He can read. Say R is for reading, W is for writing, X is for execution. Okay, so the first 3 character defines the permission of the user, okay, who logs in and on the particular directory or files. Next one is the group. Okay, so not only the files, okay, users can also be group. Okay, you can also say that you have something like 10 users working in your computer. Then again, but say you can also group them. Okay, this set of users is for web development. This set of users is for some other tasks and so on. You can group the set of users on your computer. Okay, so this next 3 character. So myself, okay, it is under the staff. So if you look at this file, this information, you see that you have SRS is the user and staff is the group name. Okay, so next 3 characters are for staff. Okay, staff can also read, staff can also write, staff can also execute. Okay, and the next 3 is others, means anybody in your computer, any user in your computer, they can read, they can write, and they can also say execute. Okay, so likewise this permission is grouped into users group and others. Okay, and depending on the associated permission, say the respective user can perform something. So let us take one example. The first one, you have RWX, then all are dash dash dash, right? So it says that the application folder can be read by the user, can be also write, can be say it can user can also write something in this directory, and the user can also run something in this directory. It can execute. Okay, but anybody in the group except myself cannot do anything because it's all dash dash dash, and others also dash dash. So that basically means other users, irrespective of whether it is in my group or not, they also cannot do. Okay, but whereas if you look at the second part, second says that user has read write executions, but again for the group has reading permission, but it does not have writing permission, and it has execution permission also, but there is no reading permission. Same thing for the other users. Okay, so likewise, so these are the set of permission that are say associated with these directories and files. Okay, and one interesting thing you can see, you have something like @ for the first case. Okay, so what does it mean? If you have @ here, it basically means that this particular directory is also having some extended permission. Okay, so if you are along with the say this permission, if you are also putting some extended meta information, some in the form of some key value and so on, then if you have extended properties, then you will have this @ okay. So I can see what are the properties. Okay, I think there is a command called extended attributes. Extended attributes can see what are, so this basically @ basically means your directory of file is having extended permission, extended attributes. So what are those extended attributes? I can see. Okay, application. So if you see that this extended attributes are like a meta information. Okay, along with the file, you want to give some meta information. Okay, you can see this is under com, Apple, quarantine, and so on. I do not know what is this. Okay, this inside this you have some attribute setting. Okay, so if you look at this manual of this extended attributes, you have many options. Okay, you can perform, you can write something, you can add some new attributes using W options. You can delete some attribute using using D options. Okay, you can clear say everything inside these attributes using -C options and so on. So using many this set of options, you can add some attributes. You can clean, you can manipulate. Okay, using the ATTR extended. X is the extended. ATTR means attributes. Okay, extended attributes. And another thing you can see here, plus. And the plus is for a security purpose, access control, ACL. So if you want to add some access control to some files or directory, you can also add this ACL. Okay, so ACL, I think different operating system has different programs to add this one, this access control. Okay, so but I think basic Linux command also provide. If I just say ls -le, I think. Okay, if you say E is for access controls, so if I say -L -L and E, okay, then and let us open any of them. Suppose desktop. Okay. Well, okay, I just type, let me just type. Okay, you can see that if you say -E, you also see these access control values. So it says that group and everyone, okay, deny deletes. Means from the desktop, anybody in the group, anybody in the computer, okay, they cannot perform delete operation because it is denied. The action delete is denied. Okay, so this is access control. Okay, these are the additional security features that are added. Okay, you can also add more security to this. Okay, but presently most of my access controls are denying the delete operation from group and anybody. Okay, so this again, so these are this one. So you can see this is user, group, and size, when was the last access time, and date and time, and so on. Okay, so this is the brief ls, and ls is something that you're going to frequently use So please do a kind of practice on different options. Okay, looking at all these options. So please play with these different options and see. Okay, but out of which, some only few of them you are going to use it. But I think, say it's a good idea to look at least see what are these options, at least for this for the sake of this course. Okay, please look at that. So that is about ls. Okay, now let us see. I have talked about the permission. Okay, so how do you manipulate the permission? Okay, you can always manipulate. Okay, so let me. So so I'm clearing everything. Okay, so I'm just, what I'm going to do is I'm going to create some files and then manipulate the say permission the way I want. Okay, so as one of you correctly mentioned, thus is a command to create some one blank files and with the default permission. Okay, so let me say thus test or something, test.txt, let us say. So when I create test.txt, so I can see that, yeah, test.txt is created. And then what is the default permission? Okay, so you can see that this is a file, and I can read and write. Okay, but I cannot execute. This is a text file, so I cannot execute. Then group can also read. Okay, but group cannot write and execute. Anybody can see this, and but they cannot write. They cannot write anything on these files and execute. Okay, these are the permission. Okay, so I want to now change the permission. I want to manipulate. Okay, so have any one of you say used say any command for changing permission? Hello. Yes, anybody? Anybody? Are you guys still attending the class? Hello?
No, sir.
Okay.
We haven't used any.
Yeah, so you are there, no problem. What about, let me randomly call Raghav Gupta?
Sir.
Okay. So maybe sometimes you make noise also, okay? Otherwise, I'm not sure whether you guys are actually physically present or not. Okay, so one of you responded change mode. Okay, it's good that you have, some of you already are using it. So as one of you correctly pointed out, change mode. Okay, using change mode, I can set the permission. Okay, so now again in the same way I'm going to do. So if I want to change the permission of this, okay, I have to define this W, R, W, and X for all the users, for the myself, group, and others. Okay, so let us see it. Everything is in the kind of binary pattern. So if I say 0, 1, it just okay. Okay, if I say 0, 1, 0, 1, okay, something like 0, 0, 0, 0, 0, 0, for example. So I have three components here. Okay, so first three bits, basically it corresponds to user. Next three bits corresponds to group, and the next 3 bits corresponds to others. Okay, so when I see this binary pattern, 101 is 5, so this is like 5. Okay, 000 is 0. This is decimal 0. Okay, so 000 is 0. So when I say 500, okay, basically it says that only user can read, okay, and execute, but cannot write, because 5 is 101, right? 101 is for 5. So it says that read is okay, but you cannot do write, but you can execute, right? So this is the bit pattern, and this is what I have here, 5. Okay, 0 means 000, no read, no write, no execution for group. This is again no read, no write, and no execution for the others, anybody. Okay, so now let me say change mode. Okay, okay, before that you can see the help for change mode. Okay, so these are the say different help manuals. Okay, you can look at that. So now change mode 500 and the test. Okay, now I'm changing. So if you look at this, now the permission is changed. So earlier it was RW, now this is R, then dash, then you have X, right? So there is no writing permission, only the reading and execution. Okay. Similarly, I can change to something like 7, right? 7 is in the binary bit pattern is a 111, right? So if I say 700, okay, then if you check the permission, then this is like read, write, X. Okay, read, write, and execution. Similarly, I can set permission for others. See, if I say 740, that means I will allow read, write, and execution for myself, and anybody in the group will be allowed to read, because it 4 will give me 100, right? But say others in the other users not in my group cannot do anything, right? So if I do this, my permission is this. So now you can see I have read, write, execution, and the users in my group can only read, and others cannot do anything. Okay. Similarly, if I want to change to something like 4744, then I can see, okay, I can so anybody can read now. Okay, so likewise you can manipulate the permission, and again here I am specifically defining the bit pattern, okay, for the respective permissions. Okay, so that is you can also put some shortcuts. Okay, so how something like, so I think I will first do something and tell you. Okay, if I say user, then user A minus, so in this case something like right. Okay, so initially what happened is TS is having read, write, and execute permission from the user. Okay, now I want to remove this X. I want only the read, write, but no execution. Then instead of 7, I could have defined 6, right? Instead of that, I can also define using some wildcard, or say some or some other options. So here, what I give is something like U. U basically means user. Okay, so this U says that any permission pattern that I'm going to give after the say following this U is only for you. Okay, only for the user. If I say G, it's for the group. Okay, if I say A, it is for all, anybody. Okay. So likewise, I can have U group and A, or everyone. So if I say U for users, okay. Others is O for others. I think I'm just missing it. Okay, I'll verify that. So U for users. After that, if I want to add or remove some permission, so what I want is I want to remove this X. Okay. So what I will do is A. A basically means either I'm going to add or remove. So after that, I'm defining minus. Minus means you remove minus X. So I'm removing X from U, user. Okay. So I am doing this for. So now I have removed, say, execution from. So execution from the users. If I want to remove R, okay. So A is for all. Okay, I just missed that. A is for all. U is for user. G is for group. Okay. U, and now if I want to add, so now I have removed read permission from all the users. Now if I want to add read permission to the user, I'm going to say plus R. You add plus read option to the read permission to the user. Okay. So now if you see here, so I have the read permission now. Now if I want to add read permission to the group, okay, this is the group. Now you can see it is group. Okay. Likewise, if I want to add, say, to everyone, if I want to add this, then I will have A, then it is -1. Okay. So now you are having read so and so. So likewise, you can change the permission. Okay. So likewise, you can change owner, you can change group. Okay. Now there is a files. Okay, I want to change group, GRP. This is for change group. Like say you want to change the group name of the. Okay, this particular file I want to change group. Okay, you can use change group. I can change the owner. Okay, instead of me, I want to change, give it to some other, or okay, a particular file is. So I want to give ownership to somebody else. I can have change owner. Okay, so you can change owner. Okay, so using change owner, you can change the say permission to the users as well as to the group. Okay. So now, so likewise, I am leaving this change group and change owner as a kind of assign home task. Okay, so please also play with change group and change owner. Okay. So now I have done with this, and RM is for removing a file. I think you have already used this. So I want to remove now. I have created a file. I want to remove RM. Okay, test remove. Okay. Then again, if I want to remove a directory, okay, you can also remove that. Okay. So, but how do I remove a directory? So now make directory. Let me make another something like test1 and make directory mkdir. I think you have already used it. So make directory. I am creating a directory called T1. T1. Inside this T1, I am creating some files. Thus T, thus A, thus B, and so on. Let us say these are the different files that I have created, and I want to delete it. I want to delete this T1 directory. Okay. So RM T1. Okay. So it is telling you, okay, like say it is saying that it is a directory. Okay. I cannot delete. That means inside a directory you have many nested subdirectories or many nested files. Okay. So you have to tell to the shell, okay, that you have to go inside and the recursively you need to delete everything. Okay. So that is nothing but RM -R. It says recursively you delete everything. Okay. So now if I say rm minus r, I will be able to delete now. Okay, so now it is deleted. Okay, so this is delete operation. Move. Okay, move is like you renaming files. Okay, one files to another I want to rename. So thus A, and I want to rename to B. Okay, now if you see here, I have a file called A, and if you move now A to B, now the file is renamed to B. Okay, so for the directory renaming, okay, you don't need to recursively because you just need to change the directory name. Okay, even if it is a directory, you can directly use move. Okay, so this is the moving. Then CP is for copy. You want to copy one file to another file, or so you want to copy from one directory to another directory, then I can use copy. So now I want to copy the file B to C. Okay, I'm copying now. Now it is okay. So now I have created C also. This copy, so the same copy of B you have created, right? So these are some of the command that you are going to use day to day, and I'm sure you might have already used. Okay, say make directory, remove rm directory, remove directory. So in the remove, I was using minus r option, but if you're using remove directory, you can directly use. Okay. Another is how to see the content in the file. Okay, one is something get or less or more. Suppose to say I have a file. Let me just see if I have some files. Is there any file? I have some HTML files. Okay, let me first copy this. Okay, so now I have created. I have a file, text file, index.html. I want to see it. Okay, so you can open this in many editors, right? I think you might have used gedit, vim, v, and so on. Some different editors you might have already used it. Okay, but what I want to do is I just want to see it. Okay, I don't want to modify or anything. So what is the content in it? Okay, so I can use get index. So when you use get, okay, it will show me the entire content in one go. And if everything comes in one, say in my desktop, it is fine. But if it is a big file and this is a big file and everything is not coming here, then I cannot probably see what is on the top, right? So get will just display, nothing else. Okay. Then if I want to see, say, scroll down and see and scroll down, then I can use either less or more. Okay, less index. So now I can. So it is showing from the first line, and I can scroll. Okay. Similarly, I can also use more. So again, I can scroll and so on. So I can use get or less or more. Okay, then this is for, and the one kill. I think today we not discuss kill because we need to create some process. Okay, kill is something like, suppose you want your system is very heavy and some process is consuming all the CPU resources. You need to kill, or say you have some program that is running in infinite loops. Okay, but nowadays in the current operating system, they have some system trigger, and if it is running in some infinite loop, it will find out that it is consuming all the CPU time, and it will create some segmentation faults and kill the process. Okay, but earlier, say it doesn't kill, so it will probably consume all the space, say, in the infinite loop and so on. So likewise, or say your system become hang because of some reason, you need to kill some process. Okay, then you can use the kill command. Okay, kill there are many options, and you can define what is the particular process ID, because every process program that you're running in your computer will have some ID, which is called process ID. Okay, so that process ID you need to give, and you can kill. Okay, so we'll see some of this operation when you talk about say process creation, fork, and so on. Okay, that time we'll see. So another commonly used that you say something that you are going to commonly use is this pipe and the say pipe and the forwards. Okay. This is the pipe. Pipe is like you are sending output of one program to as input to another program. Okay, that is the pipe. Suppose say I want to let me send the content of say one program, say output of one program. Suppose ls. The output of ls program I want to send as input to another program, say get. Okay, then I can send through pipe. It basically says output of ls command is taken as the input to the another command called get. Okay, so when I do this, yeah, so it is showing the list of say files in my directory, but this output is from the cat. Okay, so this is the pipe. So using pipe you can send output of say again you can have a sequence of pipe. Okay, so if I have said this less is again this is coming from less. Okay? So likewise in a pipe you can send output of one program as the input to another program and so on. Okay, so that is the less. Likewise, you can send output of your a program to a file. Okay, so this is this greater than symbols will send you the output of a program as a to a file. Suppose if I say this is something like test.txt. Okay, it will send the output of say ls command, this program, and create another file called this. Okay, so now the output of ls is not shown, and it will be stored in the test. Okay, so now you can see here. Okay. Likewise, you can also send. You can take input from a file to a command. Suppose I want to display this text. Okay, so I want to yeah. So I can take this file as the input to this command. Okay, so I can send to a file or I can read from a file. Okay, so this is these are the commands. And one more interesting useful command is that say creating tarball. Okay, like archiving, because archive is a very important. So I think you might have used or seen some files like tar.gz, any file with the extension tar.say say gz or something. You might have seen something like some files with something some files with tar.gz, or say some file name with tgz. Okay, this kind of file you might have seen. So this all these files, this type of files are archive file. That means you are archiving many files inside a directory. Also, you may also have many other subdirectory inside that. So if, everything inside a directory I want to archive and create as a file. Okay, then I have to what I can do is I can use tar. Okay, tar is for is a command for archiving. Then if I want to zip, okay, using either gun zip or say bzip or something, then I can also I can also zip the archive. So if I am using the gz, basically means you are using gun say gun zip. Okay, so likewise I can create. So let us see how to I create an archive. Okay, so let us see inside my test. I'm inside the test. Okay, whatever inside this test directory. Okay, you can see that I have a directory called tests. Okay, and inside this directory, I have, these are the list of files that I have. I may also have other directories. Okay, so I want to create archive of this. That's what I will do. Okay, what I can use is tar. Okay, or I can also use SAR. Okay. So SAR is a very basic archiving models. It has with lots of limitations. So mostly you are going to use tar. Okay. So let us see what is the manual for tar. So you can you can create archive with many options. To please go through these different options. Okay, I'll just show you some of the examples. So now if I run tar, I want to create. Okay. So -C is for create options. Okay. If I say create and specify F. Okay. So basically this F basically say that specify the files. Okay. So if I just say -C F, then let me give the some name like test dot tar. Okay, then what is that? Test. Okay, so now you can see a file called this test.tar. Okay, and I think I can also list -t. I just forgot this. Oops, it. Let me create. Okay, what I wanted to do is I want to show what are the files inside this. Okay, anyway, that I think I just missed that option. I will check that before that. So now it is tar now. Okay, let me delete this tar again, tar file. Okay, let me create in. So now when I use C and F, I cannot see what is what are the files that are say kind of added. Okay, I can also do verbose. If I say this, okay, so the advantage of verbose is that if you are tarring, you created tar with verbose option. When you untar, okay, you can also see what are the files that are part of that has been included into say this tar file. Okay, so this is then again instead of verbose I have given jet. Okay, B should be verbose. C B F verbose. Okay, so it is showing that these are the list of these are the list of files that you are archiving here. Okay, this is verbose. Okay, so now if I give jet here, jet basically means perform gunzip. Okay, then I can have here that gjet to indicate that the tar is gunzip, or you can also say gjet. Okay, tar with gunzip. These are the kind of standard naming conventions. Okay, so I can use tar gjet. Okay, so when I have now, so I have created a file with test.tar.gunzip. Okay, so this is the archive that this is how I can create an archive of a directory with many files and subdirectories. Okay, so I have to use, so there are many options, but this kind of CZDF. These are kind of very frequently used command options. So okay, that is what I just want. I'm just showing here. Okay. So now I want to untar again. Now I have created this archive, and now let us see how to say unarchive archive these files again. How to extract this archive. Okay. So let me copy this tar in another directory. Let me create so that test make directory test2. Okay, inside this, let me move the tar file. Now I want to archive and see what are the. I want to extract the file inside this. Okay, so say the same tar file, tar command. Now I'm going to extract. Okay, X is for extract, B for verbose, and if it is GIF, I need to ungif, and F tar dot. Okay, so now it is extracted. Okay, so now you can see I have the directory called test. Okay, I'm having the test directory. So X is for say extraction. If you are doing gunzip, use say Z, and you are B for verbose. You show what are the files and the subdirectories inside while say extracting. Okay, so then F is like specify the file names. Okay, so now I have this. Okay, so this is what the archive. So if you go inside the test, you can see what are the files. Okay. So this is about archiving, and you please okay tar it. I just wanted to show you what are the okay. Some other interesting commands for tar is that suppose if you want to, if you do not want to extract everything, okay, I just want to extract a particular this one particular file, okay. That also that is interesting thing. Let us just do and see, okay. Okay, let me just create the tar again. For tar, I already have the tar. So I don't want to extract everything, but I just want to extract a particular file from here. Okay, then I think I have to do this with minus extract verbose gif f, and let us say I want to extract A. I don't have A. I want to extract B. Not found in archive. See. Okay, something is wrong. Okay, so you can do that. Okay, I just missed that option, I think. So please, that you can do that instead of extracting everything. You can extract some specified files. Okay, so I think I just need to miss that option. Can so okay, please. I think I'm leaving this as a say your practice. Okay, so you can do that. I'm just missed the options. Okay, so now another two commands that I wanted to show is like say add users, add group, and so on. Suppose you want to add more number of users to your computer, you can use add user command, or you want to add more number of group, you can use add group. Okay, but on my machine on Mac I cannot this because users are I can create users only through the this users API for creating users and group. So I cannot run this command on my machine, but you can run if you are using Linux system, okay, Ubuntu or Fedora or something, then you will be able to use add users, okay. But I don't have, my system does not support that. So main add user, okay. So I don't have. So on my machine I don't have, but you can use add users for adding users, then change password for changing the password, add group, and so on, okay. So yeah, so now it is 3:35, okay. So we have crossed half an hour from our normal tutorial timing. So we will stop here, okay. So I will be uploading some practice questions for this set of commands, and so what we will be expecting is before next class, like Monday midnight, by Monday midnight, you should upload those, say, answer those, perform those activities, okay, those operations, and you should execute on your, you should practice that and prepare a report on that and upload, okay. So I'm expecting two types of reports. One is in the PDF. So in the PDF document, you can make, you can create in any, any template or any format, the way you feel comfortable, okay. But in the another file is the just the mirror text file, okay. Whatever you have given in the PDF, you just create a simple text file. You just copy whatever you have done on a text file and a pure text report, okay. These two files will be asking you to upload through the Canvas, okay. So so I think we'll resolve this Canvas issue by tomorrow. For that, we need to have your mail ID. So if I'm not able to get the mail ID, I'm going to share one Google Doc to collect your mail ID, okay. But please provide only IITG mail ID, okay. So that we can in future, if you want to use it for say personal communication, we can do that, okay. So we want to communicate only through the IITG mail ID, okay. So yeah, so with this we will stop for today, and we'll meet again tomorrow with more utilities. So next few classes will be on only on understanding these utilities, okay. Maybe another 2 classes. After that, we'll be starting some more programming and some more interesting discussion, okay. So I have stopped recording of this screen, and I will this recording will be available on Canvas, okay.